Three friends have a total of 6 identical pencils, and each one has at least one pencil. In how many ways can this happen? So first we're going to solve this problem using two methods. The first one is going to be simplified and the second one will take some math. So for the first method, we know that each friend, so we'll name the friend 1, A, friend 2, B, friend 3, C. And it says there are 6 identical pencils and each one have to have at least one pencil. So we're going to start by giving each friend one pencil. So one pencil we can draw like that. And then after we distributed 3 out of 6 pencils, we have 3 pencils left. So the remaining can be distributed. So 3 out of 6 pencils, and we can visualize the rest of them. So for case number 1, over here, we're going to use the same table we have. And this time we're going to give all 3 of those pencils to person number A. And then for case 2, we're going to do 2 pencils to A, 1 to B. Case 3, we're going to do 2 pencils to A and 1 to C. And then for case 4, we're going to continue this process. And this time we're going to put 1 pencil to A and 2 pencils to B. And we're going to keep doing this. So each process has 3 possible choices. So 3. And then we have 3 pencils. So we multiply it by 3. So that gives us 9 possible arrangements using only 3 pencils. So we used 3 pencils and we got 9 arrangements since we have 3 per turn. And we can do it starting from this one, like we did for this, and then for this, and then for this. So it's 3 times 3, 9, and then we had the first variation over here since it required at least 1 pencil for each person, so that's 1 possible arrangement. So we have 9 plus 1 equals 10, so our answer is D. So for the second method, we can start with the same way. So the 3 friends are A, B, and C. And then we're still going to give each friend 1 circle, and this represents the pencils this time. So for this scenario, we have 1 possible arrangement, which is the required one. And then for the remaining 3 pencils we have, we're going to do some little math over here. For this scenario, we're going to have the 5 items. So the 5 items are going to be the 3 circles that we denoted as pencils. And then we're also going to have something called bars. And bars are going to be the number of friends we have. So for this time we have 3 circles and 2 bars. And we only have 2 bars since we're only having 1 less bar than the number of friends in each row. And to find the number of ways to arrange these 5 items, where 3 of them, the circles, are identical to the 2 items, the bars. So to find out this, we're going to use the equation n factorial over p factorial times q factorial. And this just says that the number of ways to arrange n items where the p are of one type and the q are a different, in this case, which the p is pencils, the bars is q, are of another type. So using this equation, we have the n. The n is going to be 5 items we have. So the total number of items we can choose to manipulate. The bottom is going to be P, which is the pencils, multiplied by the Q, which is 2 bars. So this calculates the total number of arrangements we can have the 3 pencils assigned to the 2 people. So if we calculate this, we have 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1. You can cancel these out. Cancel the 3 out. And the 2 with the 4, so it's 5 times 2 over 1. So we get 10 possible outcomes. So the answer is still D.